Warm greetings. Welcome for online video session on software engineering. Myself Jagadish, Associate Professor, Department of Computer Science, Canara Engineering College, Banpal. In the last video session, we have seen about the design issues as well as implementation issues. In the implementation issues, we have seen three types of issues: reuse, configuration management, host target development. In the reuse, we have seen the number of different levels in the reuse. There is abstract level, object level, component level, and system level. And next we have saw the configuration management. In the configuration management, we have a fundamental configuration management activities. In that, we have seen the version management, system integration, as well as program tracking. And in the host target development, there is a third issues in the implementation issues. And here we have tools that supports the software engineering process. That is, one is integrated compiler and syntax direct editing, language debugging system, graphical editing tools, testing tools, and project support tools. These are the five tools that support the software engineering process in the host target development. As well as we have seen the issues that have to be considered in the while making a decision is the hardware and software requirement of the component, availability requirement of the systems, and the component communication. So in this video session, we will see about the open source development as well as RUP, Rational Unified Modeling Language in this video session. So here we see the open source source development. In the open source development, the name itself says it's a open source. So anyone can access the software which is open source and they can start developing the application for the customer. Here the software engineers won't pay anything for the tools that is openly available in the web services. Here they start making use of the components of open source component and they develop the software for the customer. Here the software engineer won't pay anything for any of the tools or the components that is used to develop an application. Open source development is an approach to software development in which the source code of a software system is published and volunteers are invited to participate in the development process. It's an approach to a software development in which source code of a software system is published. Published in the sense, it is source code, whatever the open source being used, it has to be published and volunteers, and it is being sold out in open, that is in web services where volunteers are invited to participate in the development. Anyone can be participated to develop a tool. Its roots are in the Free Software Foundation, which advocates the source code should not be proprietary but rather should always be available for the user to examine and modify as they wish. So no one is the owner for the open source development, open source tool. So all are as a owner, act as a owner, and all are can make use of the open source tool. And open source software is something like an extended idea by using the internet to for the large population of the volunteers can develop. And something like many of them are users of the code. All are making use of the open source code. And the best known for the source that is product is of course that is Linux operating system, Unix, and MySQL and Apache's web servers are all open sources. As examples of open source tools. Open source software extends this idea by using the internet to recruit much larger population of the volunteers developers. Many of them are all users of the code. All are making use of the open source code. The best known open source product is of course Linux operating system, which is widely used as a server system. See, think about if the open source is not available in the market, in the that is in the internet web services, then think about if any of the company, if they want to make use of to maintain a server or to make it develop a soft tool or application, they have to pay the in the larger way, where as well as for the client also it may cost for development of application in a larger way. So without open source, it will be very difficult to develop an application. Even you can think about our where there is a software engineering tool, Hoomlet, where it is open source, freely available, as well as operating system Linux. If it is Linux is not there, then everyone has to purchase the Windows, which is a paid version. So it may cost more, as well as if you want to purchase individually, it costs more than 4,000 to 5,000 per operating system. So most of the companies as well as most of the vendors who sells desktops or laptop are giving operating system, Linux operating system, which is because it is a open source as well as freely available. Nowadays even MS Office we can there is it supports Windows operating system. The same way in the LibreOffice is there for the Linux, where it works same as it is MS Office, but because MS Office we have to pay for that. Whereas LibreOffice which runs on the Linux, we both are open source. There is no need of paying even a paisa for that tool. Easily make use of the tool, but it is not user friendly. Most of the open source tools are all not user friendly as what we see in the Windows. But if you practice that open source tools, then you can make use of the same tool without paying anything for the like Windows or MS Offices. Other important open source products are Java, Apache Web Server, and MySQL database management. Some of these are all open source tool or products are available. There are a lot of there's applications are available where alternate which supports Windows as well as that is which the tools which are you have to pay. Alternate tool are available in the open source. For example, MATLAB, you have to pay something like Latch together for the MATLAB. The same thing syslab is available in the open source. It works same as it is like MATLAB. The MATLAB are used for the image processing applications. Same like syslab is also there in the open source, where we can work image processing applications. There are a lot of the tools which are all supports in the Windows, the paid version. Alternate will be available, but we have to spend a lot of time for the practice, and we have to understand the tool. We have to spend a lot of time. That's the one drawback. That's it. As well as there is no need of paying anything. That's the one advantages. Open source issues, and see, products will be developed using open source. But there is some issues also there in there when you start developing the software. There are some issues also have to be considered for when you develop a software for the company. What are the issues? Should the product that is being developed whether make use of the open source component? First one is the product that is being developed, whether we have to make use of the open source component. That is the one issue. And second one is, should an open source approach be used for software development? These are the two issues that we have to consider while developing software. The answer to this question is something like type of software that is being developed and the background and the experience of the software development team. It depends on the development team whether we make use of the open source component in the developing a product or whether we can make use of some other component but that is depending upon the development team as well as software engineering. That's one, and whether they have to make use of the approaches to be used for the software open source approaches. So that is also both of these two questions is depending upon the software engineers. One who make use of software the open source tool for development of an application, whether they make use of a software component, open source software component, or as well as whether they make use of open source approaches has to be used or not. That is depending upon the software engineer. That is the development of a software product for the sale, as well as the time to market, and because it reduces the cost, as well as that was critical in developing a product license version. If something like if you are developing software to a specific set of organizational requirement, so they want some set of components for the development of the application. It depends upon the organization requirement. Then using the open source component may not be an optional, because the tool or component that is used in open source, it won't help in the application. Then it is up to the development team to make. Because integrated your software with existing systems that are not incompatible with available open source system. Because you may develop a software making use of a open source, because it may not be incompatible with the available system as well as hardware. So at that time we cannot make use of the open source component. So that may be a problem for the even developer as well as buyer. And it would be a quicker as well as cheaper to modify the open source systems, because it is cheaper, because there is no need of paying any amount to any of the tool, as well as it will be easier for the developer also, rather than developing a different functionality that has to be needed for the application. So more and more companies, that is product companies, are making use of the open source approaches in the development. Their business model is also not reliant and selling a software products, but rather than selling a support for this product. Many companies believe that adopting an open source approaches will be reveal confidential business knowledge to their competitors, so to adopt their development model. And if you are working like in a small companies and you open source software, this may be reassure that the customer that they will be able to support the software if the company goes out of the businesses. That's one of the problem making. And publishing the source code of the system does not mean that people from the community will be necessarily help with this development. That's the issue in the open source also. And these are the two issues that we have seen in the open source. And open source business, more and more product companies are using an open source approach to development, because its cost is very less, and their business model is not reliant on selling software product. They believe that involving open source community will allow the software to develop more cheaper and more quickly, and will create a community for the user of the software. And open source licensing. A fundamental principle of open source development is the source code. Source code is very important in the open source, because you are making use of open source, whether the source code should be available for all in a internet or not, because it's making use of open source. Open source source code should be freely available. This does not mean that anyone can do as they wish with that code, because you have developed the code, you have developed the application. It's not that because maybe you are making use of open source, it's not that you have to sell, or you have not a meaning of selling. It's not that you have to freely make use of the source code or freely available. That does not mean that they cannot do anything with the code. That's what they should get a license. So legally, the developer of the code still owns the code. They can place a restriction on how it is used by including legally binding condition in an open source software license. See, you cannot, since you are making use of a software with using a open source, it is not that another person can make use of the code without a permission or from your side, because there is some restrictions will be there. So with that restriction, they can make use of the make use of the code, but without any altering the main source code. Some open source developers believe that if an open source component is used, if you are making use of an open source component is used to develop a new system, then that system should also be open source. If you are making use of, that's what I said in the last slide, if you are making use of a open source component, then that system should be also be open source. So developers will also think that whenever they are making use of the open source tool, whether they make use of open source component or not. If they make use of open source component, then that software should be open source to the system to all others with some license agreements. Others are willing to allow their code to be used without these restrictions. The developer systems may also proprietary and sold as closed source system. So they make use of the open source tool, but they won't make use of the open source components, and they allow and they go give restrictions to the source code. So that is because since they make use of the open source component or tool, then they should give a restriction to access the source code, but they won't give access to the code. So that's what is there. Then depending upon the proprietary and whether it has to be sold or not, and sold it in a open, there is whether it is a source system or there is a open source system or outside this is open source, depending upon the developers. So there are some license agreements or license model is there after developing a source code. So there are three types. One is general public license, that is GNU, general public license, they can be called as a GPL. And second one is GNU, lesser general public license. And third one is Berkeley standard distribution. First one is GNU general public license, they can call it as a GPL, or they can also call it as a reciprocal. Whereas Berkeley standard distribution they call as a non-reciprocal license. So reciprocal is a GPL, that is general public license. The non-reciprocal license is Berkeley standard distribution. So in the first that is license model, what we see that open source software that is licensed under GPL license, something like same as it is if you get a DL or a learning license, you can ride your vehicles with the L board like that. Okay. So whenever you develop a software with making use of a general public license, that means then you must make the software open source, because you are making use of the open source component. Then you should make use of that software open source in the market. So this is what the reciprocal, that is public, the general public license, because the license will be given to the product, so anyone can make use of the product in the open source. That's what, if your product is given a general public license, then that product has been sold out in the, you have to keep it in a open source, anyone can access. That is what GPL says. In a GNU lesser general public license is a variant of the GPL license, where you can write a components. You are not making use of the open source component, but you have to write a component that links to the open source code without having to publish the source code of these components. So here there is no need of publishing this the source code in the general public, in the source open source. So that is what lesser general public license. In a Berkeley standard distribution license, there is non-reciprocal license, that is opposite to the general public license, where you are not obligated to republish any changes. For example, you have developed one product. So that product is being published in the open source. And if you are doing any modification, or if you want to do, if you have done any changes, then that changes part there is no need of to publish in the open source. That's one of the advantages of making use of a journal, that is Berkeley Standard Distribution License. So that's what they said. Any of the changes or a modification, there is no need of republishing in the open source code. You can conclude the code in proprietary system that are sold. So this is what the 3 license model. So license management. So once you are making use of the that is open source license, so what are the management has to be considered in the open source. That is some of the companies are suggested in managing the project. They usually say open source. One is establish a system for maintaining information. Establish a system for maintaining information about open source components that are downloaded and used. You have to establish overall downloaded the components that is of open source, and overall making use of that has to be maintained in the system. Not in the open source, that is who have developed the open source tool, that for that whenever you download any of the open source tool, then that has been noted in the person who have downloaded at what time and whether they make use of the component, etc., anything like that. Behavior of different types of license, and understood how a component is licensed before it is being used. So you are making use of a component, and whenever you download it, that whether you have to give it whenever you develop a product or application, whether it is a open source components we are making use of or not, I have to specify. When you are making use, then it is to be licensed whether general public or Berkeley or lesser general public license. That has to be said in the license in the component itself. Be aware of evaluation, the evolution pathways for a components. Educate the people about the open source, because instead of paying and making use of any of the tool, instead of that we can make use of an open source tool. So we have educate the people about the open source. Have a auditing system in a place. Making auditing in the sense, so whether you are making use of components of open source or not, that has to be get audited, and participate in the open source community. So whenever you develop a tool or making use of open source, better it is being put it in open source. So anyone can be helpful, because you are making use of an open source tool, then it has to be helpful for the other person who want to use that tool. So this is all the license management in the open source. So next we'll see about the rational unified process. So rational unified process is same as it is that is tool in the UML to develop a software process model. This is one of the another rational unified process, and very important question, one definite question in the examination. So here you have a 3 generic process model of the rational unified process. One is dynamic perspective, static perspective, and practical perspective. In the dynamic perspective, it shows the phases or various stages over a time, and static perspective, it shows a process activities. It's not whereas dynamic is in a fixed time, whether you have completed the job or not, it is jumped to the other stages. Whereas in the static process activities, after completion it will keep on moving. And practical perspective suggested good practice, which there is stages is good for the development of a product is been decided in the practical perspective. So we have we will see the various stages in the rational unified process model. So in the rational unified process model, we have 4 stages: inception, elaboration, construction, and transition. Same as it is software process activities. In the software process activities, what we are saying: specification, development, then testing, then evolution. The same way, inception, elaboration, construction, transition give the same name, same description, but the name is different in the rational unified process model. And what we are seeing, the loop in this from transition to the inception, the loop what you are seeing, that is phase iteration. So it is nothing but the iteration process. So till you get a good product, you keep on continue the operation of the till you get the correct product of the software. Okay. Then we'll see the various phases: inception, elaboration, construction, and transition. Inception is nothing but establish the business cases for the system. Here is nothing but the simple thing, getting the goal of the inception phases to establish a businesses. You should identify all the external entities like people who are involving in the system, as well as that will be interact with the system, as well as define the interactions, etc. that has been defined in the inception. And the second one is elaboration. Elaboration to develop an understanding of the problem domain and the system architecture. So here, whatever the goal of the elaboration phases are to be developed and understand the problem domain and establish the architecture framework for the system, to develop the project plan and identify the key project risks, what are the risks has to be, and develop a UML use cases and architecture description and development plan for the software. It has been described in the elaboration. In the construction, it is system design, programming, and testing. So the system design, as well as making use of a programming, each program or there is a programming language is being used better to develop, and after that you have to test the test cases of the application. Then transition, deploy the system in its operating environment. So deploy a system is once you develop a product, then it is next stage is making use of the system in an operating environment. So these are the 4 stages what we see in the RUP. There is 4 phases in the RUP. That is rational unified process model. And in the static view of RUP focuses on the activities that take place during the development process. Static view of RUP focuses on the activities, and we call it a workflow in the RUP description. And there are 6 core processes. There is core process are there in the static workflow of unified process model, and this question is also important in the examination. We have a static workflow in the rational unified process. So what are the static? One is business model, second one is requirement, third one is analysis design, fourth one is testing, and fifth one is deployment, sixth one is configuration and change management, project management, and environment. These are the what we see. There is 4 plus 5, total 9. The static workflow is there. So one is business modeling. The business process are modeled using business use cases. So we are making use of use cases while designing a business modeling. And requirements, actors who interact with the systems are identified. So same as it is, who are all actors, what are the use cases will be identified in the requirement. Analysis and design. So a design model is created and documented using architecture models, components model, object models, sequence models, even activity model, state diagram, etc. And once design is over, then implementation. So components in the systems are implemented and structured into implementation, subsystems, etc. And testing. So once you have been developed, implementation is finished, testing has to be done. So various testings will be making use of that to test the system. System testing follows the completion of the implementation. Once the whole system has been tested, then the completion of the whole system is done. And after testing, then it's a deployment, releasing the product to the customer. And after that, configuration and change management. If any changes is required for the customer, then has to be done according to the changes, that is manage changes to the system. And project management, it supports the workflow, manages the system development. And environment, it shows the workflow in the concern with making appropriate software tool available to the software development team. So these are the 9 static workflow in the rational unified process model. And RUP is a good practice as developing a software. This is C especially. This is what I want to say once again. This is previous what we saw, the 9 phases that are static workflow in the rational unified process model. And another one is this is 6 fundamental best practice recommended by the that is practice perspective. Okay, what we have saw in the previous first that is in the rational unified process model, dynamic perspective, static perspective, and practice perspective. So what we have saw is for there is first one is a dynamic perspective, and static perspective what we have saw the 919 workflows, and this is what the practice perspective. So they can ask what are the practice perspective, or what are the fundamental best practice perspective in the examination. Okay, they can ask six fundamental best practices are development software iterative, manage requirement, use component based architecture, visual model software, verify the software quality, and control changes to the software. So these are the six best fundamental practices perspective in the RUP. And develop a software iterative. So plan the increments for the system based on the customer priority, and develop the highest priority system features. So based on the customer requirement, so he may require, that is, he will be giving a number of that is components has to be developed. So based on the priority, start developing the components. Manage the requirement, that is explicitly document the customer requirements and keep track of changes to these requirements. So a customer may come and says any changes in the development of a system, so that has to be managed and keep documented. That's what it says in the management requirement. Use the component based architecture. So structure the system architecture into the component and discuss it, and this was structure the system component architecture as a whole. That is architecture has to be developed according to that. If subsystem architecture also has to be noted down in the system. And visual model software. Visual model software is that is use a graphical UML model to represent a static and dynamic view of the software. So we have a lot of UML models are available in the tool. So according to that, static model and dynamic static view and dynamic view, make use of that while developing software. Verify the software quality. Ensure the software meets organization's quality standard. There are some standards has to be maintained by developing a software, whether it meets the standards or not. Control changes to the software. So manage the changes to the software using a changes management system and configuration management procedures and tools. So these are the various 6 fundamental best practices recommended by the RUP. And by this we have completed a third module, all the topics. If you have any doubt, let me know in the online session. Thank you all.